Yeah, welcome back everybody. Let's continue straight from where we stopped. The next one is number 3. One of the roots, that's number 3. One of the roots of the quadratic equation x squared minus 4 plus p times x plus 12 equals 0 is 3 times the other. Find Roman figure 1, the roots of the equation, and Roman figure 2, the possible values of p. Now the quadratic equation is x squared minus 4 plus p times x plus 12 equals 0. Let alpha and beta be the roots. If one of them is 3 times the other, that means I can say alpha equals 3 beta. Now alpha plus beta is minus b over a, and in this equation b is minus into bracket 4 plus p. So that means alpha plus beta equals minus into bracket minus into 4 plus p over 1. That's minus b over the whole of this is b. So minus b is what I've just written, and that's going to be 4 plus p over 1, which is the same as 4 plus p. So that means alpha plus beta equals 4 plus p, and alpha is the same as 3 beta. That simply means 3 beta plus beta equals 4 plus p, which means 4 beta equals 4 plus p, and that means beta itself is 4 plus p, or you can write it as p plus 4 over 4. Now the product of the roots, which is alpha beta, is the same as c over a. C in this equation is 12 and a is 1, so alpha beta is 12 over 1, which is the same as 12, and we know that alpha is 3 beta. That simply means 3 beta times beta equals 12, which means 3 beta squared equals 12, and that's the same as beta squared equals 4, which means beta equals square root of 4, which means plus or minus 2. So how do we find alpha? When beta is equal to 2, alpha is equal to 3 times 2, which is 6, or when beta equals minus 2, alpha will be 3 times minus 2, which is equal to minus 6. That means the roots are okay, when alpha is 6, beta is plus 2, so the roots of equation are 6, 2, or when alpha is minus 6, beta is minus 2, 6, 2, or minus 6 minus 2. Those are the roots of the equation. The roots of the equation are 6 and 2, or minus 6 and minus 2. Now Roman figure 2 says, by the way, that was Roman figure 1, 3 Roman figure 1. That was Roman figure 1. And Roman figure 2 says, find the possible values of p. So beta is equal to 4 plus p over 4. When beta is 2, 2 will be equal to 4 plus p over 4. And we cross multiply it to get 4 plus p equals 8. Of course, this is 2 over 1. So that means p equals 8 minus 4, which is equal to 4. And when beta is minus 2 will be equal to 4 plus p over 4, which simply means when you cross multiply, we get 4 plus p equals minus 8, and that's the same as p equals minus 8 minus 4, which is equal to minus 12. So that means p equals, what's the first value I got for p? P equals 4, or p equals minus 12. So those are the two possible values of p. Now we go straight to the next, which is number 4. Number 4, if alpha and beta are the roots of the quadratic equation, p minus 7 times x squared, p minus 7 times x squared plus px plus 2p equals 0, where p is a constant. Express alpha plus beta and alpha beta in terms of p. Hence or otherwise, find Roman figure 1, the equation whose roots are 1 over alpha and 1 over beta, and Roman figure 2, the values of p for which the roots are equal. First of all, I'm going to find, okay, they said find alpha plus beta in terms of p. Now alpha plus beta is minus b over a. A is p minus 7, b is p, and c is 2p. So alpha plus beta, which is minus b over a, will be minus p over p minus 7. That's alpha plus beta in terms of p, and alpha beta in terms of p will be, alpha beta is c over a. That simply means 2p over p minus 7, which is the same as, yeah, that's 2p over p. That's simply 2p over p minus 7. That's alpha beta. Now we've done that. We now want to find, Roman figure 1 says the equation whose roots are 1 over alpha and 1 over beta. The sum of the new roots, which is 1 over alpha plus 1 over beta, is equal to LCM is alpha beta, and alpha beta divided by alpha is beta. Beta times 1 is beta. Alpha beta divided by beta is alpha times 1. That's alpha. And we know that beta plus alpha is the same as alpha plus beta, which is minus p over p minus 7. Minus p over p minus 7. I want to write that well. Divided by alpha beta, which is 2p over p minus 7. 2p over p minus 7. And that's the same as minus p over p minus 7 times p minus 7 over 2p. And that simply means p minus 7 here 1, p minus 7 here 1, and that's simply the same as p here 1, p here 1. That's simply minus 1 over 2. Now the product of the new roots, which will be 1 over alpha times 1 over beta, is equal to 1 over alpha beta, which is the same as 1 divided by alpha beta is 2p over p minus 7. I hope that's correct. Yeah, that's correct. 2p over p minus 7. And that's the same as p minus 7 over 2p. Now the equation whose roots are 1 over alpha and 1 over beta is therefore given by x squared minus sum of roots, which is minus 1 over 2 times x plus product of roots, which is p minus 7 over 2p equals 0. And that's the same as x squared plus 1 over 2x plus p minus 7 over 2p equals 0. And now to clear the fractions, I can multiply through by 2p, and that simply means 2px squared minus px plus p minus 7 equals 0. So to write the equation in one on a single line, I think I want to write it as 2px squared minus px plus p minus 7 equals 0. Plus p minus 7 equals 0. And that's the equation whose roots are 1 over alpha and 1 over beta. 2px squared minus px plus p minus 7 equals 0. Now we go straight to 4 Roman figure 2. 4 Roman figure 2. Find the values of p for which the roots are equal. If the roots are equal, that means b squared equals 4ac, which means the square of minus p, that's b, is equal to 4 times a, which is 2p, times c, which is p minus 7. And that simply means p squared equals 8p into bracket p minus 7. And that means p squared equals 8p squared minus 56p. Minus 56p. Now, I can move p squared to the right hand side to have 8p squared minus p squared minus 56p equals 0. Equals 0. And this is the same as 7p squared minus 56p equals 0. And this simply means 7p into bracket p minus 8 equals 0. This is supposed to give us two values because it's a quadratic equation, two solutions because it's a quadratic equation, and this is the same as 7p equals 0 or p minus 8 equals 0, which means p equals 0 or p equals 8. Of course, if you divide both sides by 7 here, you get p equals 0, and from here p is equal to 8. So the values of p are therefore p equals 0 or p equals 8, and that's the answer to that, very, very simply. Now we go straight to number 5. Given that 4 into bracket y minus 2 all squared equals k into bracket y minus 1, where k is a constant, Roman figure 1, show that the sum of the roots equals their product. First of all, I want to open the brackets before finding the sum of the roots. 4 into bracket y minus 2 all squared. 4 times the square of y minus 2 is the same as 4 into bracket y squared minus 4y plus 4 equals, the right hand side becomes ky minus k. And if I open the bracket, I'm going to get 4y squared minus 16y plus 16 equals ky minus k. Now moving the whole of this to the left hand side, I'm going to get 4y squared minus 16y plus 16 minus ky plus k equals 0. And this is the same as 4y squared minus 16y minus ky plus 16 plus k equals 0, which is the same as 4y squared minus y into bracket 16 plus k plus 16 plus k equals 0. Now I want to rewrite that as 4y squared minus into bracket 16 plus k times y plus 16 plus k equals 0. Now the sum of the roots, is therefore equal to minus b over a, which is minus into bracket minus open bracket 16 plus k all over a is equal to 4, and that simply means 16 plus k over 4. That's the sum of the roots. Now product of roots, we have to show that the sum and product of roots are the same. Product of roots equals c over a, which is 16 plus k equals c over a, which is 16 plus k over 4. 16 plus k, this is c, 16 plus k, and this is a. So product of roots, which is c over a, is the same as 16 plus k over 4. And we can see that that's the same as sum of roots. Sum of roots is 16 plus k over 4, and product of roots is also equal to 16 plus k over 4. Therefore, sum is equal to sum of roots is the same as product of roots. Now to Roman figure 2. Find the values of k for which the difference between the roots is 3 whole number 3 over 4. Let alpha and beta be the roots. That means the difference between those roots, which will be alpha minus beta, is 3 whole number 3 over 4. And that means alpha minus beta equals 15 over 4. Now what is alpha minus beta? We can find that from the square of alpha minus beta. The square of alpha minus beta is the same as alpha squared minus 2 alpha beta plus beta squared, and that means alpha squared plus beta squared minus 2 alpha beta, which is the same as alpha plus beta all squared minus 2 alpha beta minus another 2 alpha beta, and this simply means alpha plus beta all squared minus 4 alpha beta. This is the square of alpha minus beta. Let me write it. Alpha minus beta all squared is equal to alpha plus beta all squared minus 4 alpha beta. That therefore means that alpha minus beta itself is the square root of the whole of the right hand side. Alpha plus beta all squared minus 4 alpha beta. Now, alpha minus beta is 3 over 3 over 4, which is 15 over 4. That simply means the square root of alpha plus beta all squared, the square root of alpha plus beta all squared minus 4 alpha beta is equal to 15 over 4. And that simply means square root of alpha plus beta is 16 plus k over 4. That's the sum of the roots minus 4 times product of roots is also 16 plus k over 4. And the whole of that is equal to 15 over 4. The whole of that is 15 over 4. Now, I almost made a mistake. Alpha plus, this is the square of alpha plus beta. So it's supposed to be 16 plus k over 4 all squared. Now, squaring both sides, I'm going to be left with 16 plus k over 4 all squared. Here, 4 here 1, 4 here 1, minus open bracket 16 plus k equals 15 over 4 all squared. That's what you get when you square both sides. And that simply means 16 plus k all squared over 16 minus 16 minus k equals 225 over 16. That's correct. Yeah, that's correct. And now 16, the square of 16. Okay, clearing the fractions, what do I have? Let me clear the fractions. If I clear the fractions, I'm going to get 16 plus k all squared. That means I'm multiplying the whole of the equation by 16. I'm multiplying through by 16. Minus 256 minus 16k equals 225. And that simply means I can open these brackets now. That simply means 16, or maybe I should write this first, plus k all squared minus 256 minus 16k minus 225 equals 0, which is the same as okay, let's see, which is, now I can expand this. If I expand this, what do I have? If I expand the square of 16 plus k, that's the same as 256 plus 32k plus k squared minus 256 minus 16k minus 225 equals 0. And this simply means 256 minus 256 is 0. Now 32k minus 16k is 16k. That means 16k plus k squared minus 225 equals 0. And let me just rearrange that. K squared plus 16k minus 225 equals 0. And now, can we solve that by factorization? Yes, we can. That's k squared plus 25k minus 9k minus 225 equals 0. And that's the same as k into bracket k plus 25 minus 9 into bracket k plus 25 equals 0, which simply means k minus 9 into bracket k plus 25 equals 0. And this simply means k equals 9 or k equals minus 25 or k equals minus, I want to make sure that takes, I want to write that on a single line. That therefore means k equals 9 or k equals minus 25. And that's the answer, very, very, very simply. So we go straight to the next, which is number 6. the roots of the equation 4x squared minus 12x plus 7 equals 0 are alpha and beta, with alpha greater than beta. Find the values of Roman figure 1, alpha minus beta. Alpha minus beta is equal to the square root of, we've shown that already, alpha squared, the square of alpha plus beta all squared minus 4 alpha beta. And here in the given equation, alpha plus beta is minus b over a. That's minus into minus 12 over 4, and that's 12 over 4, which is 3. Alpha beta is c over a, which is 7 over 4. C is 7 and a is 4. So alpha beta is 7 over 4. Therefore, alpha minus beta is equal to the square root of alpha plus beta squared, which is 3 squared, minus 4 alpha beta, which is minus 4 times 7. Let me make the root longer. Times 7 over 4. And that's equal to the square root of 4 here 1, 4 here 1. And that's 9 minus 7, which is equal to root 2. That's alpha minus beta. Roman figure 2 says alpha squared, find the value of alpha squared minus beta squared. And this is the difference of two squares. So it's the same as alpha plus beta times alpha minus beta. And that's equal to alpha plus beta is 3 times alpha minus beta, which we already found. That's root 2. And that means alpha squared minus beta squared is 3 root 2. And that's it, very simply. Let's take a breather before we come back to it. And we'll continue from number 7 in the next. Thank you very much, and I'll see you. Bye-bye.